Hello, welcome to Latency Exchange. On this channel we discuss technical topics relating to low latency trading, concentrating on the exchange side concepts, technologies and processes. I'm Dave Beattie, a solutions architect specializing in low latency exchanges. In this first series of videos I will detail my architectural solution for a 24/7 low latency exchange. In this video I will detail the communications that support the functions of the core zone. I will focus on the general flow of the communications and the resiliency options that are available. There are two distinct areas in this zone. The central area is where the main functions of the trading happen. The network landing pads is where all of the trading institutions' links are connected. I will start with the landing pads and then address the central area. There are two landing pads for resilience, and there should be no direct interconnectivity between them. You don't want to be in a situation where a BGP or spanning tree failure could take out both pads. As a minimum, a trading institution should have two links, one to each landing pad. These links would have to carry all traffic relating to that trading institution. There are three types of traffic that we need to consider. Trading traffic includes orders and pricing requests, and this is all destined for the core zone. Market data traffic comes from the market data servers in the core zone, but this may also include retransmission requests where the messages have been lost in transit. Administrative traffic may include requests for position or trade summaries. It may also include the submission of risk threshold rules or even kill switch activation. This is usually aimed at the back office zone, so segregation from the other types of traffic must be done carefully. Trading traffic must arrive at one of 4 gateway servers allocated to that trading institution. There are 2 of these servers associated with each landing pad. To limit the volume of outstanding trades that a trading institution can hold, the number of open trades would usually be limited per login or per landing pad. This would mean that the gateway servers on a single landing pad effectively act as a failover pair. The number of links to a single institution might go as high as 8, 1 for each gateway server, 2 for market data, and 2 for administrative data. The actual solution will be based on what the exchange wants to offer and the cost. The protocols in use can either be standard ones, like FIX, or proprietary ones that are aimed at accelerating the trading. The gateway servers that trading institutions use can be structured in a number of ways. Firstly, monolithic. In this case, there is a single gateway process running on each of the 4 gateway servers, and all trading institutions connect to these. This has the benefit of simplicity, but suffers from a lack of scalability. It also opens up the possibility for one institution to impact the trading performance of another. Secondly, dedicated processes. In this scenario, each institution has a dedicated gateway process to use on each server. This offers a good amount of separation for each institution and hugely increases the scalability of the solution. In the extreme, each process could be pinned to a core on a CPU, so that it will always be available for use. This means that different institutions could use different protocols, such as FIX or proprietary. Finally, dedicated servers. In this scenario, each institution has their own physical servers to connect to. This gives the greatest amount of separation for the institutions, but adds a significant limitation on the scalability of the solution due to the number of servers required. It also adds hugely to the cost and complexity of the solution, not only in terms of the number of servers needed, but also in terms of the networking that is needed to support this number of servers. When looking at the MiFID requirements for fairness, it is acceptable to have different trading institutions connecting over different methods, so long as they were all offered all of the options. Control of the volumes of take-up for each option would probably be achieved through pricing. There are 4 market data servers arranged in 2 pairs, one pair aligned to each landing pad. Within each pair, one server is active and is responsible for sending all of the market data to the trading institutions via that landing pad using a multicast transport. The landing pads will contain the logical functionality to restrict the market data feeds sent to a specific trading institution based on their entitlement. There must also be provision for a retransmission service. This is likely to be hosted on the same servers using a separate process, but could be hosted on the standby servers. Administrative traffic, as previously described, is generally destined for the back office zone. For this reason, it is better to be transmitted over separate links, but it could be overlaid on the market data links to save cost. Additionally, it should be noted that this traffic might come from a different location within the trading institution, so separate links may be needed anyway. Due to the fact that this traffic is not considered low latency, the bandwidth of such links could be very much reduced. Within the central area, all primary communication is over multicast. Traffic must be sent over all 4 physical paths and then deduplicated upon arrival at the destination. Ultimately, multicast transmission must be considered unreliable, and this brings us to the third data function to be co-located with the data extractors and data injectors, that is, the data guardian. The 4 data guardians listen to all 4 copies of all multicast messages within the core zone. If a data guardian finds that it has missed a message, it can request an update from the other data guardians using a special multicast group. This way the 4 data guardians can stay in sync. Depending upon the configuration parameters of each of the data feeds, the data guardians may keep data stream messages until archive, or may purge them on a rolling time basis. If any other server finds that it has missed a message, it can ask the data guardians to send it using another multicast group. It is expected that the 3 data services, extractor, injector, and guardian, will reside on each of the 4 data services servers. If the exchange is particularly large, multiple data guardian processes may be used, each protecting messages on separate multicast groups. Ultimately, these services could be separated onto individual hosts, but this adds to the cost and complexity of the solution. When an error occurs, it must be logged locally on the relevant server, but it must also be relayed to the central logging servers in the management zone. In the solution service definition, there is a catalogue of error codes. Each error is associated with a number of criteria, which are the error severity, the affected subsystem, the unique error code, which is derived from these previous 2, the text description of the error, the required capture information, for example, host name or interface ID, and the muting factor and unit. This describes how long the server should refrain from reporting this same error again, either in seconds or in number of occurrences. In the case of transmission errors in the core zone, a server might report that it did not receive a message over one of the 4 transmission paths. Its muting factor might tell it not to report this again for 10 seconds. If the error clears within 10 seconds, the server should report that the error has cleared and include the number of occurrences. If packets are still being lost on that interface after 10 seconds, the server should then report this along with the count of occurrences in the preceding period. This aims to prevent the logging servers from being overrun in the event of the failure of a critical piece of infrastructure that is used by many components. Optionally, each error code may have a local muting factor, so that the local log could be protected in the same way. One of the principal aims of having a centrally collated log is so that the Exchange platform can be aware of issues as soon as they arise and can determine that such logging will be expected until this issue is cleared. It also helps predict hardware failure based on increasing frequency of sporadic issues. The next video will look into the new modules and functions that will be needed on servers within the core zone. Thanks for watching. Please leave any questions in the comments and I will reply to them as soon as I can.